In the seventh topic, we're going to start proving trigonometric identities. Now, you know that if this angle over here is theta, that's x, that's y, and that is r. We're going to use our definitions in terms of x, y, and r to prove these two trig identities. When you're proving an identity, please always draw a line and do your left-hand side and right-hand sides completely separately. We are trying to prove that this is true. We are not solving an equation. So in terms of x, y, and r, tan theta is y over x. Sine theta is y over r, and we are dividing by cos theta, which is x over r. You know that when you divide by x over r, you are going to invert and multiply, tip and times, our r's are going to cancel, and we land up with y over x. In other words, our left-hand side is equal to our right-hand side. Now what this means is, it does not matter what size your theta is. Okay, tan could be, your theta value could be 30 or 150 or 700 degrees. Doesn't matter how big theta is, tan of that angle will always give you the same answer as sine of the angle over cos of the angle. The next identity we are going to try and prove is that sine squared theta plus cos squared theta is equal to 1. I've done my line in the wrong place, so I'm going to put 1 on that side and deal with the sine squared plus cos squared on this side. Sine squared theta plus cos squared theta. Now sine is y over r. Sine squared is going to be y squared over r squared. Cos is x over r. Cos squared is going to be x squared over r squared. When you add your fractions, your lowest common denominator is r squared, and your numerator is y squared plus x squared. But of course you know from that little right angle triangle there that x squared plus y squared is equal to r squared. So on this side over here we have r squared over r squared, which is 1, okay, and your left hand side is going to equal your right hand side. Now, there are a couple of identities that if you do AP maths, you're expected to know. You can prove them in the same way, but I'm not going to prove them here. You have to know that sec squared is 1 plus tan squared, that cosec squared is 1 plus cot squared. You also have to remember that cosec is the reciprocal of sine, and that sec is the reciprocal of cos. So these are only for the AP students. Now, when we do proofs going forwards, we're not going to use x's, y's, and r's anymore. It gets quite messy. We are going to use these to prove every other identity. And there are a couple of things, a couple of methods to try. The first rule is, if you can, use your square identity to get rid of your plus or your minus sign. So in this side over here, that 1 minus sine squared, I am going to write as cos squared theta. I'm using this identity to get rid of that minus sign. 1 plus tan squared, unless you are an AP student and you know it is sec squared, all you would be able to do there is write tan as sine theta over cos theta, and we are trying to prove that that is equal to 1. Sorry, I should have said cos squared theta. When you multiply in that bracket, cos times 1 is going to give us cos squared theta. Cos squared times sine squared over cos squared is going to be sine squared, and this identity, sine squared plus cos squared, is 1. So my left hand side is equal to my right hand side. In this example over here, I can't use my squares identity. Please remember that this sine theta plus cos theta means the bracket multiplied by itself. When you take that product, you get sine squared theta plus 2 sine theta cos theta plus cos squared theta. The moment you are adding or subtracting squares, check to see if potentially you can use this identity over here. And we know that sine squared theta plus cos squared theta is 1. And this side, the left-hand side, becomes 1 plus 2 sine theta cos theta. Our left-hand side is equal to our right-hand side. In this example over here, everything is already in terms of sine and cos. Your powers are very different. On this side, you've got powers of 4, on that side, powers of 2. So what I'm going to do on this case is factorize. Sine to the 4 minus cos to the 4 is actually the difference of 2 squares. And it's going to become sine squared theta plus cos squared theta multiplied by sine squared theta minus cos squared theta. Sine squared plus cos squared is 1, and we have 1 multiplied by our sine squared theta minus our cos squared theta. Our left-hand side is again going to equal our right-hand side. The next example we're going to do, okay, none of those previous examples have helped us so far when it comes to something like this. Can I use my squares identity to eliminate a plus or minus? Clearly not. Right, in terms of sine and cos, it's already done. Tidy up my fractions. There's nothing to tidy up. It's as tidy as it's going to be. There's nothing to factorize. There are no brackets to multiply. So what we're going to do in this particular case is we are going to multiply by a very special number 1. Okay, cos theta over 1 plus sine theta. Now what I'm going to do is choose my number 1 so that the denominator becomes the difference of 2 squares. Okay, I'm choosing what we call the conjugate. Number 1, well, anything divided by itself is the number 1, and you know that when you multiply by number 1, you get the same answer. Now my numerator here is going to be cos theta multiplied by 1 minus sine theta, and my denominator becomes 1 plus sine theta times 1 minus sine theta, which is 1 minus sine squared theta. 1 minus sine squared theta is going to be cos squared theta. And when I cancel, this cos divides into the cos squared in the denominator, cos times, and again I land up with a left-hand side is equal to my right-hand side. The last trick I want to show you is pretty much when all else fails, okay? In this situation here, can't use my squares identity to get rid of a plus or a minus sign. Everything's in terms of sine and cos. There are no fractions to tidy up. There are no brackets. I could factorize this side, but it's not going to help at all. Certainly it's not a situation where a special number 1 would help. So if you look at this, on the left-hand side, I notice that I only have sines. So the thing I don't want on the right-hand side is that cos squared theta. I'm going to replace that cos squared theta with 1 minus sine squared theta. 1 minus sine squared minus another sine squared, 1 minus 2 sine squared theta, and my left-hand side is equal to my right-hand side. Now let's put all that together into another example. On my left-hand side here, I have 1 minus 2 sine squared theta all over sine theta cos theta. On my right-hand side, cos theta over sine theta minus tan is replaced with sine theta over cos theta. I'm simplifying fractions. That means I need to find my lowest common denominator. Sine goes into sine cos, cos and cos times cos gives me cos squared theta. Cos divides in here, sine squared times sine times sine is sine squared theta. My denominators are now the same. I have a cos squared here, whereas I don't have a cos squared on the left-hand side. So I'm going to replace that cos squared with a 1 minus sine squared. And my numerator is 1 minus 2 sine squared theta all over sine theta cos theta. My left-hand side is equal to my right-hand side.